Hi! In this video, I'm going to demonstrate a CVaR optimization using the solver in Excel. I'm using the closing price of 5 assets from healthcare sector in Malaysia as my data. We need to find the number of scenarios that we will be using. Here we have 200 scenario returns for each asset. To find the scenario return, use the formula final minus initial divided by initial. Drag it across and downwards to get all the values. To let us navigate easier, we can hide some rows by doing this. Right-click your mouse and then choose Hide. Now we're going to calculate the expected return of each asset by using the average function. Drag it across and there we got all the values. Next, let us look at the weights. We are using equally weighted for this part and the weights will change when we use the solver later. The sum of weights must always equal to 1 and we should double check this by using the sum function. Now we are going to calculate the return contributions of each asset's Rij. From now onwards, we are using all the data from the scenario returns instead of the closing price. The formula for this is scenario returns times the weight, but don't forget to put the dollar symbol because we only want the column to change and the row remains the same. Drag them to get all the values. This is the CVaR formula by Rockefeller and Uriasef. First, we are going to find Rix, which is the sum of Xj times Rij. We are using the sum function. To find the V, which is VAR, we set the alpha to 5% and the total scenario is 200. For the add position, we use the round function of alpha times the total scenarios comma 0. This is to make sure the value that we will get is a whole number. To find VAR, use small function for all Rix and the add position. The VAR is located at the 10th position of our sorted Rix. Now we are going to find maximum value of V minus Rix. Use the max function with VAR minus Rix, comma 0. Don't forget to put the dollar symbol accordingly. Pi is the equally probabilities, which is 1 over 200, our total scenarios. To calculate this, we are going to choose Pi and times with the maximum value. Now we can calculate the sum by using the sum function and choose the Pi times max column. Finally, We can find the CVaR by dividing the sum with alpha and minus the VAR. To set the portfolio return for equally weighted, we use the MMULT function, which returns metric products of two arrays. The first array is weights, while the second array is the transpose of the expected returns. So here is the result for our equally weighted CVaR optimization. Now we are going to minimize CVaR by using the solver. First, create a target return for our new CVaR. For example, 0.01. This value is flexible. Go to the Data tab and choose Solver. For the objective, we are going to choose the CVaR. Set this to minimize. For this part, the changing variable cell, we will choose our weights. Now we are going to add the constraints. Choose the sum weights as our cell reference. Set this to equal and this as 1, which is the composition of the portfolio. For the next constraint, choose the portfolio return for equally weighted as the cell reference. Set this to more and equal, and the constraint is the target return. These are all the things that we need to set in the solver based on our CVaR model. CVaR is our objective, minimizing, and the constraints. Now we can solve this. Just in case the solver doesn't work, you can double check a few times. So this is our new CVaR, VAR, and the weights of the portfolio. We can manually check our VAR values too. Copy all the values of RIX, paste it here by using the paste special values only. Now right click to sort from smallest to largest. To see this clearly, let's put the number here. Our VAR is at the 10th position, as you can see. That is all for today. I hope you can understand how to use the solver in Excel for your CVaR optimization. Thank you.